Chapter 3.1, quick review, 1 through 10. Section 3.1, our book, has to do with exponential, modeling using exponential and logistic functions. And these exercises in the quick review have to do with leading up to that. We're going to be looking at things related to exponents. In exercise 1 through 4, evaluate the expression without using a calculator. Well, what we have is we need to know our cube roots. We have, for example, 3 cubed is equal to 3 times 3 times 3, or 27. So we say, therefore, that the cube root of 27 is equal to 3. Also, we can write this as negative 216 to the power of 1/3. But also, we can have the cube root of a negative number, for instance, negative 27, and that will equal negative 3. Now, in this case, the cubes, if we go to 4 cubed, we get 64. If we get 5 cubed, 5 times 5 times 5 equals 125. And finally, 6 times 6 times 6, which will be 36 times 6, is 216. So the cube root of negative 216 is going to be negative 6. Negative 6 times negative 6 is 36, and 36 times negative 6 is negative 216. So this will be our answer to problem number 1. Problem number 3, we have 27 to the 2/3 power. We have, in this case, instead of a radical root, we have a rational root. And this third right here, this would be a cube root. And this will be like 27 to the 1/3 power squared, right? Because the squared here is a power in the numerator. So squared. So we have a combination of the 1/3 power, 27 to the 1/3 power, and then squaring that. And this is always easier number-wise, I found out, if you can take the cube root first to be working with smaller numbers. So this is going to be equal to, so 27 to the power of 2/3 is equal to the cube root of 27 and then squared. And so the cube root of 27, well, we actually happened upon that, didn't we, in the last problem? Cube root of 27 is 3. So we're going to have 3 squared, which equals 9. So that is our answer to problem number 3. Now, if we had squared 27 first, we would have had a large number. We would have had 27 times 27. That would have been, what, 49? 7 times 2, 8, that's 18. And then 2 times 27 would be 54. So we'd start out with 9. 729. So the cube root of 729 is going to be 9. That's if we square first, but it's easier if we can take the cube root of that 27 first. It just makes the numbers more manageable. In exercise 5 through 8, rewrite the expression using a single positive exponent. And so for this, we're going to be really getting a refresher on our laws or rules, we call them sometimes, of exponents. And I don't know how much time you spent last year in Algebra 2 with laws and rules of exponents, but essentially we're going to combine, this is called the power rule, the power of a power of a power. And for that, we multiply. So this negative 3 is multiplied by the 4. So we have 2 to the, we have 2, so negative 3 raised to the 4th is equal to 2 to the negative 12th power. And then we can use the rule of negative exponents. And for that, we take this negative 12th power to the negative 12th power. We can make this 1 over 2 to the 12th power. And so we've removed all of our negative exponents. And that's going to be our answer, number 5. Number 7, we have a to the negative 2 power raised to the 3rd power. Same concept, the power of a power. So this is going to be equal to a to the negative 2 times 3, which is going to be a to the negative 6th power. And using the rules of negative exponents, that's going to be equal to 1 over a to the 6th power. So that's our answer. Just a basic review, a review of the laws of exponents. Next, in exercise 9 and 10, use a calculator to evaluate the expression. So this is just an example of plugging using our calculator. In this case, I have a TI Inspire calculator, and I press Control and this exponential key. We're looking at a 5th root of negative 5.37824. And we press enter, we get negative 1.4. So we go back here, put it here, negative 1.4. And then we can work backwards. We could take this negative 1.4 to the power of 5. We should get what we had earlier, negative 5.37824 checks. So this would be our correct answer. Good luck on your even number problems to demonstrate learning. And thank you for viewing.